Hi guys, this is FireWave and welcome to episode 2 of setting up the Outpost map. So in today's episode I will show you guys how I did the camera movement, so to basically go and have a closer look on the buildings. Also, just as you've seen on screen, the camera movement going from left to right. I'm going to show you how I did that. And lastly, I'm gonna show you how I did the character animations, so just to liven up the scene. Okay, so let's get started with the camera movements. So for that, in the scene, okay, as you can see, I've placed several cameras. So these are basic camera actors. I just typed camera over there. And here, camera actor. You can find them here, drag them into your scene. No problem whatsoever. So I've placed a few. And what I did, if we go into here, cams, I basically grouped the cams according to the buildings. So you can see that I've got the garage cams, the headquarters, training, and the wall as well as the overview looking over all the camp. So how do I make all of this work? So first of all, we need to go back into BP, so it's the Outpost Manager. In the Outpost Manager, okay, I'm just going to quickly close the functions, no spoilers. I have basically set up an event. So basically, I start by setting the camera to the overview so that we can see the scene, the all scene. So if we go into this function, it's basically a set view target with blend where I input the camera of the overview, I get the player controller, and that's basically it. I also have an enumerator to keep a track of what camera is active. That will be helpful later on. So once it goes through there, then I create an event, which is this one. So to create an event, it's in the event dispatcher. You can just create one like this. For example, new event, let's just keep the name like that. Drag it into the scene, do a bind, and basically each time you call this event, wherever in any blueprint that references the BP manager, you will basically call an event. So if you press dot here, add custom event, name your event, and you will execute that piece of code just there. That's how I did the blueprint above. So now, what do I do when I call this event? So first of all, I have a variable called can switch subcam. So that basically means I am not in the overview camera and I can do the movement switching from one cam to another to have that animation. So then what do? I have a macro called set subcams. So that's basically me setting up two variables called active subcam 1 and active subcam 2. And there I get my variables from the scene. So you can see here, subcams here in variables, I've defined active subcam 1, active subcam 2, but I've already got subcam headquarters 1, 2, garage 1, 2, training 1, 2, and so on. So basically, if I go back here and select Outpost Manager, here on the left side you can see subcams where I basically inputted, okay, well, headquarters has this one and this one. So they basically consist of this camera here and this camera right here. So that's basically how I reference the cameras into the blueprint manager, and that's how I define the variables. So great, on this point I've got the cameras I need to switch back and forth for the animation. And then how do I do the actual animation? So it's with another macro that I've created. Oh, basically to create macros, you go just here, create plus, name it, do whatever you need to do, and if you go back into the event graph, just drag and drop it in it. If you don't see the input pins, you can see that this macro doesn't have an input pin in it. I'm just gonna get a break function, for example. You just need to drag and drop the executive pin into the inputs and outputs of the macro. Basically save that, go back in the events, and voila, you've got the input and output. You can do the same to have basically any type of variables. So here I've got camera actors, you can have floats, booleans, whatever your heart desires. So let's go into rotate camera. So I started with a variable called flip-flop for subcams. So I decided to create a boolean instead of using the flip-flop functions included in Unreal. I'll explain that why in just a second. Okay, let's break this down. So I'll go back and forth between the end and the beginning of the blueprint, but let's start with there. So I do a sequence. So this is basically to close a gate that happens later in the blueprint. It prevents the camera switch if the user go again shortly on the building. I'll show you an example of why I do that. So I start by doing a delay. So this delay is basically, if I go back here, okay, it's the delay before the managers start switching between the two cams. So you see there was 4-second delay. That's basically the delay that I've just put there. Can switch sub cameras. So this is basically if I am in overview, it goes false and it breaks the whole loop that I've created. If it's true, it's because I'm in building view and the loop goes on. So now that's basically where the magic happens. So remember that the top pin here is for sub camera 1 and the bottom one is sub camera 2. This one is just to get the player controller. So, can switch subcams? Yes, what do? I switch to sub camera number 1. And I input then the sub camera 1 pin, so this is the camera actor, and beneath is the controller. Oh, sorry, this is the controller, this is the camera. If I look into the settings, blend time is the time for the transition, so for one camera going to the other. The blend function is basically how do you want the smoothing transition to be. Do you want it to be linear, so it sort of is a linear speed during the 6 seconds? I chose ease in and out, so that means that the camera movement at the beginning is slow and reaches its maximum value, and then at the end it decreases the speed, just so that we get a nice smooth animation. Blend X is just how long does the acceleration takes to reach maximum speed. You can experience with this number if, for example, I input 5. You can see that in the example that I'm going to show you just there. So basically wait for 4 seconds. You're going to see that, okay, 5 seconds. Whoa, the speed is really fast. But you can see that the movement is, well, different basically. Just experience with whatever suits your boat or floats your boat. I did too. I found it interesting, so that's basically what I did too. Then what do? I do another sequence and a delay. So I do a sequence and a delay, and then there's a gate. So gates, I'm gonna explain gates first. Gate allows the exit node to process if the gate is basically open. If it's closed, any input that gets here gets rejected. This will not be executed. So you can say that it starts closed or it starts open, it's a boolean. So you can see that I've got something that closes the gate, and if we go back, it's at the beginning of the macro. Because when the player selects a building and go into building view, I want to close that gate because these delays can still be happening while player is switching from one building and another. So this can trigger the next part. So that's basically why I did a gate. That prevents the camera switch happening way too fast or in a bizarre manner. Also, I do a delay 6.1 second, so it's basically the blend time plus an extra 0.1 second just to ensure that the blend has actually finished. Otherwise, it will create some weird camera movements. Yeah, so that's basically why I did the sequence at the beginning, and this is why I do a gate. Afterwards, I enter my main loop. So I still do the variable can switch subcam. So am I in the building or am I on the overview? If I'm on the overview, then the loop breaks. Then I do a flip-flop, so flip-flops for subcams. So that's why I do a boolean instead of the flip-flop. because when switching buildings, if I use a flip-flop, it will remember the sort of pin that it has to exit, even though I'm changing buildings. So for example, I can be moving onto sub-camera 2, exit the building, enter another building, and if I use the flip-flops, it will then trigger the set view blend with the camera it's not supposed to blend with. So that's why I did my own boolean, and I ensure that whenever I enter a new building, it is in a state that I can force, and it prevents weird camera movement going onto the sub camera that it's not supposed to be. So that prevents this, and then well, it's basically go onto sub camera 1 or go onto sub camera 2. For the blend time, I did 12 seconds. The reason why this is 6 is because if I go back here, let me move backwards here. Oh, there it is. I start looking at the building with a sort of middle camera, and my blend camera, the camera animation goes back and forth between these two. So I decided that the distance between this one and this one should be 6 seconds, and to avoid any quick movements, the switch between this one and this one would be double, so 12 seconds. So that's the reason why this one I start with 6 and then I go with 12. And then the rest is I basically tell the flip-flop system, okay, so next you're gonna change which camera is activated. And I still do the delay with a 0.1 added to it, and I still do the same gate system, because the problem with which I described here can repeat itself here. If I'm in a transition, if I'm in the delay, if the delay is activated here and I switch buildings, this will trigger the loop, and this is a way for me to break the loop and prevent, once again, weird camera movements. So with that, I explained to you how I did the camera movement. So this basically system where I can look into the buildings, and the camera can sort of pan from one angle to another to have a better overview of the scenery and the building that I've created. And yeah, if we go back here, it's going to be the same result. The detail panel is quite large, but once again, yep, here you go. Oh, well, that's a perfect transition. I'm gonna tell you now about character animation. So, I decided to input characters into the scene to make it more lively. And how do I do that? First, I'm gonna explain to you a few things. So, in the assets, so as I told you, I use Cinti assets for now it's like 99% of the game. And Cinti has animations. So I've bought the idols and locomotion animations. Unfortunately, it's made for Unity. There's not yet an export for Unreal Engine, but there's nothing to worry about. It's pretty simple to sort of use them. And this is going to be a short tutorial on how to do that. So first, if you buy the Cinti animations, you will have the opportunity to download the source files. So this is basically the source files here. If you open up, for example, I'm gonna open up idols, I've got these files that I need to import into Unreal. So quickly, textures is the texture for the dummy pack that is included here in the characters. It will be useful later on, so you will need to import all of these files. And animations here is basically the main folder containing all of the animations. So you can see here they've got Polygon and Sidekick. So quickly, Polygon is the characters included in Cinti's pack, and Sidekick is something Cinti developed, but I'm not going to use it for the foreseeable future because I don't know how to import Sidekick characters in Unreal yet. So basically, once you've done that, so idols, animation, okay, you can see that, here. Okay, I'm gonna go quickly onto the other animations because I've imported the mesh the character I've just showed you here. Okay, so there you go. You import the animation folder, the character folder, and well, in this case it's called demo textures, but it's still gonna be 2 textures, nothing to worry about. So characters, you will get your here the skeletal mesh of the polygon Cinti character that is compatible with all of the animations that you've purchased. Yep, so it's him basically. And you will need to do something that's called an IK rig. IK rig is basically a file in which you can define, okay, so these bones included in the skeleton will be a part of some retarget chain. So you can see here that root is part of the root retarget chain. So you do basically a right click and it's a new retarget chain. For the hips, so it's the retarget root. So this is the two exceptions. And then for the rest, you can basically follow what I did here. You select the three bones, right click, and you do a new retarget chain. You will have this pop-up saying, okay, how do you want to name that chain? And be careful how you name that. They will be important. Although Unreal allows you for automatic naming, so that's good. The only thing you need to worry about is on clavicle left and clavicle right. If you do that, the new retarget chain, it will propose left arm as a name, but be sure that you name it left clavicle and for the other one, right clavicle. So just gonna, yeah. So this is how I retargeted the character in the animation package. And then what you need to do is do an IK rig for the characters imported in your polygon packs. So for example, if I go back here, I said Cinti, Apocalypse, Meshes, and then characters. Yeah, you can see here we've got a bunch of characters. I basically work with the businessman. You can work with any of them as long as they're a static mesh. And yep, going back here, Cinti, animations, locomotion. So yeah, I created an IK rig selecting the businessman. Oh, by the way, IK rig, you create them by searching for IK rig. Once you pop that up, you'll have to name it. And once you open it, you'll have to select the skeletal mesh right here. So that's something you need to know. Yeah, so basically once you, let me delete that quickly. Once you've done your IK rig for the the businessman, so once again you need to repeat the whole process of retargeting your chain, so root, retarget root, spine, neck, and whatsoever, and don't forget about left clavicle and right clavicle. If you don't do that, you will get errors on how the retargeting animation, well, the output result will not be usable. Okay, so you've got your two IK rigs. And what you need to do then, it's an IK retargeter, so for the pronunciation. Once again, just type IK retargeter and name it and, well, open it up. Let me just delete the one there. And what you will have to do is here on the right side, select the source and select the target. So you'll have to select the correct IK source and the correct IK target. Just a quick memo, the source is the one that came with the animations you purchased, and the target is the mesh you want to actually animate. This is pretty much all you have to do there. Once you did that, you'll have to click run in retarget up there. It should automatically associate the bones between each characters. Normally that should be it. You can check here in the chain mapping that everything is correct. All the bones, the retargeting chain has been correctly selected. And once you do that, you should be able to browse all of the animations that came with the mannequin. And going with this one, you can see that, well, the animations is perfectly retargeted. That's all you need to do for now. Going back into the content browser, so if you go back into the animations folder, so for example, locomotion, run, okay, let's select these for example. What you need to do is select them all, right click and select retarget animations. So what it will ask you is to, well, you can either select a two skeletal mesh and it will attempt to do what you just did automatically. Otherwise, you can untick auto generate retargeters, select the one you've created, and you know that everything will be good to go. So then you just need to select all the animations that you want to retarget. Oh, actually, all selecting does nothing. It will try and search for all of the animations you've got in your project. In my case, 1,553. So be sure to search which one you want to convert. Otherwise, it's going to take a lot of time converting, trust me. And once you've selected the ones you want to retarget, do export animations. It will ask you where do you want to save them. Do you want to add a prefix to the animation? And you will be given this. So if I go into my character animation, so I've exported idols and locomotion. If I go back into idols, you can see that all of my animations are linked to my businessman, and they are working correctly. So if I open this one, you can just see him standing idly. That's how you basically import animations into your project. If you buy animations on the web, basically that's what you need to do. Okay, so this was how to get the animations and how do you actually animate your characters into the scene. So I'm just gonna finish here on the animation montage. Animation montage is basically, all of these are individual animations. So you can create basically something called an animation montage, where basically you say, okay, I want to play this animation, then this one, and then this one. So for example, here he's eating a snack. So that is basically animation montage. It's easier to work with in blueprints rather than doing, okay, play this animation, this animation, this animation. It saves you some trouble. And how you do that is you search for animation montage, should be here, yeah, this one. Select it, you select the skeleton. So mine is, I selected the skeleton from the businessman that I've just talked about earlier, and it's a named scale human character. Open that, so then you go back to your content folder, you just basically drag and drop into the default group here the animations you want to do. Do all that you need to do, the sequence that you basically need to do. Once you're happy, save it and you're good to go. So let's move on to characters. So I've decided to basically create a parent called BP Aliasing. So I'm going to use parenting. So parenting in coding is really simple. You have a parent. This parent will have some variables, will have some functions, and any child of that parent will basically be able to use those variables, those functions. So, for example, if I open it, I've defined some stats. So, for example, current health points, max health points, walk speed, run speed, and some status like can move or is alive. And basically, if I create children of that blueprint, so by doing a right click, create child of blueprint class, these child will be able to inherit all of these variables. So that's what I did in Outpost 42. I've created three. Oh no, sorry. I created first this one as a child of the BP Alive thing, in which I created a little bit of code that I'll show you just afterwards. And then these three characters are children of this one. So normally if I open this one, code is minimal. Don't worry about that, I'll show you what it is and how it works. Well, in a second. First of all, what I did for alive things, in the construction script, I did this little bit of blueprint. So I set the relative location of the mesh by the half size of the capsule component. So basically this capsule that you see right here, I'm taking this half its size and I'm subtracting the mesh's location. If you don't do that, then the character will be placed. Well, it seems I can't show you, but basically your character would have its feet where the arrow is. And basically you would have your character floating midair doing all of the game. So that's why you need to basically do this little piece of code. It brings the character to the center of the capsule that you can see right here. The main interesting thing happens in NPC X. So here in the event graph, so I first start by saying, okay, I do a little random delay before playing the animation of the character. I then do the delay, and I enter a loop. So the loop basically is, okay, what animation do I need to play? This is basically a function, I'll go into it in a second. It returns the animation time, did I spawn a mesh for the character, and the set mesh. So then I set these variables. The animation time, I then do a delay. It's the same delay that I've done right here. I add a float between 1 and 3 to a little bit randomize the animation time, so not to make him play back to back. And then I follow the loop, so I re-trigger the delay and re-trigger the animation to play. And I also do, is there a mesh to delete? If there is a mesh to delete at the end of the animation, that's why I got the delay time for animation here, then I destroy said actor. Something to note, delay time for animation and delay time for next animations are two different variables. The main difference is I add a random integer for next animations, but I am not gonna wait for this extra second to destroy the said actor I'm adding to the character. So, animation to play, how does it work? I have an enumerator that I've created that basically lists all the possible animations I've created yet. So basically switch on this enum. First of one, I'm gonna do move last. First one is pick nose, something really classic. I do play anim montage. I select the anim montage I've created. I've shown you that earlier. Play rate, I leave it to default. This I say none, I don't need it at this point. So this one, I don't spawn a mesh, so I set the variable as false. And the return value is the time of the play anim montage, so I set that as a variable. Underneath, I've got like eat snack, so eat snack is pretty much the same, although I spawn a mesh, which is basically a snack. This is basically the same, but I do a spawn actor snack 11. So the spawn actor, I've created a blueprint, an actor that I've named here as snack 11, and it is basically just a static mesh of a snack. If I can just see it, well, here you go. This is the snack. You can't, sorry, let me go back here. You can't say here, I want to basically spawn a static mesh. You have to basically create a blueprint actor. I've searched, it's pretty tedious to do a static mesh, and I didn't even find a solution to do that. So easiest way to do, create an actor, it'll save you tons of trouble. Initially this will be a pin, so spawn transform. If you do compile on that, it will give you an error. To solve that error, just do a split structure pin and it will work. Here, do always spawn ignore collision, because if there is collision, for example with the hand, it will not spawn the snack, and we want the snack, the character is hungry. I left that default value, and these two I don't use. What I do next is set collision to, well, no collision basically. So I basically untick this variable. I then get the root component of the mesh created, and I attach it to the human skeleton. Great transition, by the way. Back here in the characters that you've got from Cinti, well, in my case, you have the skeleton here. So what I did is, in the skeleton tree just here, where I've got the arm bone, I created a socket. So basically I did right click, where was it? Oh, sorry, I need to right click on the bone. Add socket, and I basically named it cold food. So this is basically to spawn the snack and spawn it at the correct place. Because if I did spawn at the right hand right, the snack would spawn here at the center of the gizmo, and not here where I wanted to spawn. So it would look weird. And the good thing with the sockets is I can place them however I want and not destroy the skeleton of the character. Okay, so during this socket, I can here in the code, select hold food as the socket to spawn the snack. So all of them I do snap to target, and that's basically it. I also set as a variable the output of this to keep a reference of the snack so I can delete it later. So this is basically the end of the function. I return the animation time, did I spawn a mesh to destroy, and the mesh to destroy. Last was another animation, but it's basically the same as begin those. Yeah, with that leaves us to the move. So one type of animation I did is basically make a character move from one point to another. I'll tell you how I get the point locations in a second, but basically I do an array of vectors. So vectors with the locations of the points where the character has to move. What I do is basically I get the length of the vector. So normally it should be above 1 point, because otherwise it will stand at 1 point and not move. Get the location index. I basically do an increment. I don't do a local variable for this one. If I did, it would be destroyed each time the function is played. So the location index would always be 1 if I start at 0. So that's why I don't create a local variable for this one. Then what I do is I do a modulo. Then I get the actual vector which I want to move the character to. And then I basically set the animation time to 3. I make sure that the character can move to the next point in less than 3 seconds, because move actor doesn't have any actual output of how long it will take to do the movement. So move actor is not a Unreal function. I basically did a event. So event, you right click and do add custom event. And I did an AI move to. So selecting pawn as self, destination, I get the destination from the function, and that's basically it. That's how I move. Okay, and with that, there is one last thing to know. You see that in animation to play, there is an enumerator. But how do you define this enumerator, and how do you define, okay, which animations can my character play? Yeah, going back to the characters, so from the BP camp NPCs, I create a child, and in this child, I basically do, I set the array of animations to play. As simple as that. And doing so, I can select what animation should this character be able to do. For example, can he move? Or should I delete this one and should he only do these animations? And this basically gives you an opportunity to not duplicate your code over and over to each character that you create. That's basically the magic of doing parenting with your blueprint. And in doing so, let me go back to, so this time blueprint, outpost, buildings. Let's take headquarters for example. That makes it so that in my headquarters, I have some blueprints. I've created these in previous episodes, which is basically called BP NPC spawn location. It's basically an empty actor that I've created. I basically use them just to get some locations. So in my headquarters, for example, I've placed a few of them. There's 4, so I've got 2 characters, 2 for each characters. And that's so these BP locations in the event graph, I get them. I get a world location and I make an array that I pass into the actor that I create. Oh, by the way, I spawn the actor on the first location, and then I give it the locations in which it can move. To get this pin, going back into NPCx, animation vars, yeah, here you go. The animations the variables that you create here in your parent, they should be instance editable and exposed on spawn. Doing that will make it that this pin actually shows when you create your character. So I created character 1, character 2, and the result is this. So if you press F8, you actually exit the camera and you can move as you wish with the mouse. And yeah, so you can have a scene that is more lively with characters moving around, having animations, and it's pretty good. One last thing to note for the animations, you will need something called a recast Navmesh in your scene. So this basically allows a certain area for the AI to move in. So I basically created this area here, so it's the yellow outline, and to actually visualize where your AI can walk onto, in the editor just press the P on your keyboard and it will show you this green area, and this basically means okay, NPCs can walk on this area. Beware though, so pressing F8 to exit. Yeah, beware that when you spawn some static meshes, the Navmesh will dynamically identify these meshes and generate collision. So for example, here the character will not be able to move an inch closer to the table. This is as far as it can go. Okay, one thing you need to enable to have your character, the Navmesh, actually identify in your static mesh as collisions. In your recast Navmesh default, you need to search for something called dynamic. Runtime generation, you need to select this one as dynamic. And this will allow the Navmesh to identify, okay, this is an obstacle, AI should not go there. I did say it was the last thing, but I lied. In your parent character class, if you go into the self, you will need to enable something called, so if you search for AI and scroll down a little bit, you can see something in pawn, auto process AI. You will need to select place in world, or actually I'm gonna change it, I don't know why I didn't change it, place in world or spawned. So this means that AI will take possession of your characters and enable them to move across the map. Okay, to finish this episode, I'll just tell you something. Well, it's specific for Cinti meshes. I had a problem with the ground. Well, actually, I had a problem with my characters. My characters would, so if I go there, my characters would basically float above ground, and I could not figure out why it would do that. So I found the solutions, well, I found the problem. If you go here into the lit, you can see something called player collision. So player collisions basically will show you the collisions for your characters. And basically the ground that I was using was not as you can see right there. It was more like this, a sort of primitive shape. But you can see that if I do the lit, the shape doesn't exactly match the the collision of the ground. So to solve that, it's pretty simple. You select your mesh on which you notice your character floating, you go to it, you open it. So first thing, you need to actually enable the player collision view. Next thing is you're gonna basically remove collision as to create something new. Here in convex decomposition, you're gonna increase this value to something you find pertinent for the shape complexity of your mesh. So I'm just gonna do an example and put all of them to the maximum. Click apply, and I will get a more precise collision option for my mesh instead of just a box. So for example, if I disable and go back onto lit, and you can see that there is some sort of surface to the mesh and its collision. It's not perfect. If you want to do something perfect, you open your mesh on Blender and then do what you need to do with collision and import it again here into Unreal Engine. But that's basically enough for what I need to do. Okay, so this is it for episode 2. I hope you found it useful. I'll come back with episode 3, in which I will basically improve the buildings, improve the animations, and I will also do the UI to basically have the buildings be useful. Okay, and with that I wish you a good day. See you guys next time.